right, please pay attention. This lab is very important because, yes, Basilis. So next meeting is going to be a Monday. That's a photosynthesis lab. Then Wednesday we're going to have a nice review session. Then the Monday after we're going to have our exam. I don't know the 14th. Is it the 14th, the 15th?
That's not week 6. That's week 7.
Okay, yeah, so that's how it is. So we're gonna, next meeting, photosynthesis. The meeting after that, review session. The meeting after that, exam. You solve the riddle. What day is it? What month? Okay, we have a lot to do. Some part of this lab, we're not going to do them, but you're still responsible of understanding their concept. So, today we're going to be discussing diffusion and osmosis. Diffusion and osmosis. And we talked about that in the beginning of the semester, and we said substance, when you put them in a beaker, if you have one beaker, that's very important. If you have one beaker that is separated by a barrier, and you make the barrier selectively permeable, or you make it differentially permeable, you have 500 millimoles of glucose here and 100 millimoles of glucose here. People think that 500 is like a weight. If you're like 500 pounds, you're so big, and 100, you're so thin. No, that's the number. There's like about 500 here molecules, 100 here. So, if you open up the chamber, if you open up this barrier, why are you guys talking? I keep hearing, no, stop talking here. Please stop talking. Completely. Absolutely. So if we make a barrier here, what's going to happen? I'm going to ask you that on the exam. What's going to happen is, from an area of a high concentration to an area of a low concentration, the substances are going to move. They're not going to move forever. They're not going to move till you have 600 here, 0 here. They're going to move until they even out. 500 plus 100, that's 300. So 300 millimoles on both sides. That's if the substance itself is moving. Now what if you add water here? So you don't begin with glucose. You begin with 1 liter of water. Side A, you have 1 liter of water. Side B, you have 1 liter of water. And on side A, you put 500 millimoles of glucose. And here you put 100 millimoles of glucose. And you make this membrane only permeable to water. So no 500 is going to move there because it's too small. Only water can move. What's going to happen now?
It's still going to move and even move.
No, because it's too small for glucose. I said that. The barrier is too small. You have to pay attention to what I'm telling you. The barrier is too small for glucose. So these guys are not moving. The 500 is not moving. The 100 glucose, because it's glucose, it's not moving. But they are all bathed in water. So what's going to happen is water is going to move from an area of a low solute concentration to an area of a high solute concentration to dilute, because water has many properties. It has high specific heat capacity. That's why we use it for sweat, for thermal homeostasis. Water has cohesion. It's a versatile solvent. That's why it has osmosis. Nobody else besides water has the property of osmosis. If you replace this 1 liter water with ethanol is not going to go. It's not going to move. It's not going to do that. Okay, yes?
So diffusion is from an area of high to low, and osmosis from low to high?
Osmosis is only for water. Nobody else has the property of moving to dilute others. Because what is osmosis? Osmosis, we're moving from an area of a low solute concentration to an area of a high solute so we can dissolve it. So that's one of the properties of water. So in this lab, we're beginning with Brownian movement. What is Brownian movement? That's also on your exam. Brownian movement, they call it Brownian because the scientist who discovered it, his name was Brown. What he did was, he realized whenever you have a water solution and you put a dye on it, is this dye, and you observe the way the dye moves, is the dye gonna go straight down like that? Or it's gonna make like trips like this, like that, like this? Is it gonna be A or is it gonna be B?
B.
It's gonna be B. So he realized that why is it zigzagging? It's because the bombardment with water, the collision with water. So the solvent molecules are colliding. They are colliding and bumping. They are bumping with this solute. So the solvent is bumping with the solute. So our first part is to have a slide and put on the slide this, we put solvent water and we add a solute and we put a cover slip and then we look in the microscope, we zoom things really wide and we will see that this movement, they are fighting, they are pushing each other. So, and that is because of diffusion. So now this solute is diffusing in water, pushing from an area of high concentration, the dropper cap, this dropper cap that you use in lab, this dropper cap, you squeeze it and then there's a lot of solute here and now it's pushing its way into the water. The second part of the lab is we're going to get an agar gel. This agar gel is like in a petri dish, like this, in a petri dish. What's gonna happen is we're gonna make 4 holes. One hole that's gonna be controlled. One hole is potassium permanganate, and that's red color. That's red potassium permanganate. On the west, we're gonna have another hole, and we're gonna put in this hole malachite green. And on the south, we're gonna put in this hole methylene blue. Okay, so what is so special? What's so special is that the red one is really dense. It's the heaviest one. That's the most dense. That's number one. That's the biggest. That's the highest molecular mass. It has the highest molecular mass. Followed by the malachite green. That's the second molecular mass. It's the second heaviest. And lastly, your methylene blue, it is the lightest. So what you're gonna do is, in this hole, you're gonna drop potassium permanganate. On this hole, you're gonna drop malachite green. And on this hole, you're going to drop methylene blue. And you're gonna leave the petri dish alone. And when you come later, what do you expect to see?
The potassium and sit down.
So what do you guys expect to see? If you drop in each hole, you put these solutions and you leave the petri dish alone for a whole day and come back, what are you gonna see?
They're gonna go to the top.
They're probably gonna spread around.
Yeah, they're gonna spread around. That's the excellent word I'm looking for. So they're gonna start spreading out. They're gonna start diffusing. This one is gonna go, let me go to the west. Let me go to the north. Let me go to the south. Let me go east. This one too. You can say, let me move upward. Let me move eastbound. Let me move westbound. Let me move southbound. This one too. Let me move this direction. They're gonna try to spread out. But you're gonna find something that's really interesting. What is the something that's very interesting that we're gonna find? Are they all going to, yes?
I was gonna say they would go to the top circle.
They're all gonna move to the top circle.
Yeah.
Very interesting. Why do you think that? They're all gonna move to the top circle.
Because it has nothing there. so it's gonna move from west high to west low.
Very nice. Very nice. They're all gonna start spread out from an area of low concentration, from an area of high concentration to low concentration. Very good. But how is the picture gonna look like? Yes.
I feel like it's gonna be a combination of multiple colors. Like let's say like the red would mix with the blue, and the blue would mix with the green,
Yeah.
and then they'll all mix together. And in the center it'll be like a color that's like a gradient that's all of them combined.
Okay. That's a good hypothesis. Who else can give me a prediction, a nice prediction? Who else can tell me what do you guys think? These are all excellent, very good predictions. You know, predictions, they cannot be wrong. Predictions is your assumptions, okay? And you need those because that helps you develop your scientific intuition. Yes, Dola.
I was gonna say the same thing, but I think it'll turn brown. Like we can put everything together once they all mix in. It just will become one random like dark color.
Like a canvas.
Yeah.
Like a canvas when you mix up all the colors together. Okay, that's good try. But all of this is wrong. What's gonna happen?
Oh, okay.
What's gonna happen? That's how science is. You know, Thomas Edison said that people tell him you have made 10,000 wrong ways to make the light bulb. He said, I have learned 10,000 ways that don't work. So now you're gonna learn that, yeah, these things, so you don't repeat them. What's gonna happen is I told you a keyword. Nobody mentioned that one keyword that I said. I said the weight. I said red color, and that's the most dense. And this is the second dense. And that's the, yeah.
I did say it was dense.
Yeah, so what is that going to give us? Yes.
Are they gonna layer on top of each other, or are they gonna take out more space?
So when they start moving, they're not going to move at the same rate. So the guy who's the lightest is going to run like methylene blue. He's going to cover most of the space before everybody else gets there. Because he's so light. He's so thin. So you're going to see most of the petri dish is going to be methylene blue. Really quickly, he's going to go through the agar gel. Then followed by our good friend, malachite green. Is going to cover a little bit less than that. And then the potassium permanganate is going to be like a little blob here. Because it's so heavy, it moves so slowly. But what she said is also true. That they're all gravitating. Here they are impeding each other. They're colliding with each other. But that's a free zone. That's the wild, wild west. They're all going there because no blocking it. So this experiment is just trying to tell you that molecular weight, molecular size is one of the big determinants of diffusion rate. In addition to temperature, if you heat things up, if you have two agar gels, one is hot and one is cold, when one that's hot, the movement is going to be faster. If you heat up potassium permanganate and you have a cool potassium permanganate and they're all the same size, they're all the same mass, the hot one is going to move faster.
How they function after is going to be different.
What do you mean?
Because if potassium, the heated one is moving faster, it's going to process differently than the cold one. So
yeah, it's gonna move. So now we're just talking about who gets to the other side first. So the weight is gonna play a role. The heat, how hot things are, is gonna play a role. The pore that we get, the medium we're passing through. If you replace this agar gel, this solid gel, if you replace it with like a water solution, oh, they'll be all over the place in no minute. They will be all over the place in no time. So this is just teaching you the factors. And the experiment so these were all experiments that we were gonna do, but we have the equipment to do the next one. Please pay attention because other class, they were mixing the things up. So what you're gonna do now is you're gonna look at diffusion. So you're gonna prepare two solutions. Solution number one, obviously you need a solvent. Solvent. Okay, and your solvent on the first case is going to be ethanol plus iodine, iodine. And then you're going to have a dialysis bag. Then you're going to have a dialysis bag. On the dialysis bag, you're going to have starch. Starch, what is starch? What is starch? We already talked about our micro and macro molecules. What is starch? Is it a protein? Is starch a protein?
Carbohydrates.
Carbohydrate, excellent. So you're going to put starch, and with starch, you're going to put water. On the next experiment, you will have another salt. That's the solution. That is the solute. That is the solute in the dialysis bag. And this is the second dialysis bag. On the inside, you're going to have phenolphthalein, and you're going to have with it water, and phenolphthalein and ethanol, and on the outside, you're going to have sodium hydroxide, NaOH, plus water. So these are our two experiments. We're going to be looking at Okay, are we ready?
Yes, we are.
Okay, so that's the first experiment. Now each group is gonna get a beaker. Please make sure you rinse out all these beakers. So let's have a game plan. Let's have a game plan. What are we gonna do? We're gonna have beaker. So outside on the beaker, what are we gonna have? We're gonna have the solvent. On the beaker, we have a solvent. The solvent is going to be ethanol and iodine. So prepare ethanol and iodine solvent. Then I'm going to hand out the starch, the dialysis bags. Inside them you will put starch and water. And then when you dip it in the solution, what's going to happen? Please listen, that's the most important part. The solvent is going to go from an area of a high concentration of ethanol and iodine to to an area of a less concentration of ethanol and iodine. And what's going to happen is it's going to move into the starch. And whenever ethanol and iodine interact with starch, iodine is going to turn blue. So we're going to go from colorless starch water solution into blue because iodine went in there. And here, the sodium hydroxide is going to go inside and interact with the phenolphthalein, and that's going to turn pink, showing you that the water or the solvent went from an area of a high concentration to an area of a low concentration. So, every group, please make sure you rinse out your beaker. Rinse out the beakers, all of the beakers, and make sure every group has a pipetter. So now we're preparing. So come pick a beaker, please. Each group, come and pick up a beaker. Rinse your beaker, and let's make a solvent. You guys seem very excited about it. You guys are so excited.
We have methanol, ethanol, is that what it's called?
That's fine.
And,
So now, what are you gonna have in your solvent? Yeah, very good. Up to you. So the solvent always gonna be more than the solute. So you're gonna maybe fill it out halfway. So put more ethanol, put like 2 milliliters of ethanol and a couple of drops of iodine. Okay? Okay. Okay. So that's your iodine. Did you guys rinse out your beakers? So now yeah, you can take your question. Go there. Take ethanol. Fill it with like 3 milliliters. Ethanol is right there.
You know, when you really like somebody, how about me is like when I like somebody, I like really
Move to the ethanol.
It's winter,
Get
let's be like.
the ethanol before you miss out. Okay, alright. Okay.
I don't care. No, we're gonna
So, you need to
No,
make
because
a
I'm gonna
solvent.
heal from
So you can put that up to you. Make it like 3 milliliters.
I'm just gonna.
No, outside 3 milliliters. Obviously, the iodine is gonna be like.
He's saying, it's very like.
So you spin, you move up, and you spin back to
Yeah, it never made nobody see that I had to. It was like as long as you didn't have it.
Wait.
Yeah.
See, do you want me to reset that? That's what
Yeah. I don't know. I really make
It's not have to be
It's
exact.
like you're walking back.
What is your beaker?
I don't want back I just like had like 4
She's
that
holding it.
I had to like.
She's trick or treating.
Waiting on him.
Look at my back.
I'm trying not to stop. She's gonna be something process.
Say, all you have to do is one meat.
Yeah.
Why is there? So the only already in there.
All you have to do is
Prepare your solution.
Oh,
Okay, you're not just watching, you're watching and understanding what's happening because that's going to be on the exam. Yeah. Drops. Guys, is that a solution? That is tiny.
Wait, you said
So add much more. Chanel, I said add like 15 milliliters.
No, you did not. No, you're throwing
Sorry.
What's her point?
Yeah, so use this pipette for starch and a separate pipette
And the
for
girls are going for it, imagine how to do
that for starch.
Okay, oh, I know.
Yeah, they're gonna dissolve the bag, you know? You guys need to fill it like halfway.
I don't even have it. What's his name? Well, I don't have it. I'm good.
Come on, more, don't be afraid.
Let me get them back up on this side.
He just said no electronics. Who's saying the one thing he's looking for is electronic, bro?
Something that you put the bag in.
He did it on his.
I think I used it correctly. Just that I'm
It wasn't working. It just wasn't.
No, it was working. How do you think I got pointed?
Oh, that's
Oh, wow.
Just take one second. All right, if you're not working with the pipette, you gotta make the dialysis bag. Sophia? Glucose. No, that's not, no,
It's not for
no.
this, right?
That's not.
That's for the solvent.
The solvent, yeah, you just make it in the beaker. The sugar goes inside the bag. Yeah, look, since you're not doing the
Starch.
the pipette, tie the bag. So I'm gonna show you guys, if you are not doing the pipette, make sure to prepare your bag. You guys have one. You guys.
Professor Kadir?
So basically we're that?
No, this is
Solvent. I'm trying to make this solvent for the second one.
What is it called? It's gonna, no, you don't need to, you just need to use it to tie the end of the bag so it doesn't leak out.
I guess.
This is gonna tie it. Okay, if you do not have a dialysis bag, and you need a string,
Oh, fill it halfway.
dialysis bag and a string. Dialysis bag, who does not have a string and a dialysis bag? Okay, every group has a string and a dialysis bag. Okay. Okay, I'm gonna show you how to open it. Listen up. Okay, so don't worry about opening it for now. I'll show you how to open it. This is what you gotta do. Hold on to one end. And everybody who has a dialysis bag, paying attention. Like this, you fold it up like that. Like this, the end. You fold the end. Then make like an accordion. Not, you know the accordion? Like this. Yeah, keep folding it. And then take the string and make a knot. See? Yeah. But you don't, like this, like that. Yeah, and then you tie. So you make an accordion. Very good. Now you're gonna make a second one for the next for now?
Yes.
Okay, and I'm gonna show you how to open it. It's enough, it's not gonna leak out, you're good. Next. Yeah, excellent. Okay, so now we're gonna open this, dip, wet the top of it. So if you wet it with water, it's gonna start to come out. So just wet it with water. That's easy. Well, you guys motor skills, I don't know. Your motor skills, maybe because you are so young. You guys were born in the year that I was a freshman. You guys are babies.
During the summer.
Make a like
Started it?
That's it, right? Hold on.
Yeah.
Yeah, I don't know what you Just like fold it up like that.
Yeah, just wet it some more.
He
So,
said.
so first of all, you make a fold, then you make an accordion, like this, like that. And okay, so you gotta wet the top. Until it opens.
I don't know what you're saying, it doesn't open.
Be patient. I don't wanna mess it up. Okay. See, she opened it. I need to be more patient. I did. What is that? It's outside, yeah. So move at your own pace. Yeah, make your solvent. Move at your own pace. I don't have to tell you, now it's time to do that. Now it's time to do this.
Don't expect it to put his hands.
Yeah, look. That's it. No sodium. Just starch and water. Sodium and sodium. So you put water here and you put starch. That's the starch.
It's just.
Up to you. Like hamburger. So we're supposed to have many bags, and the more starch we add, then let's examine how fast it goes through.
But he's like, oh, you're all not over there.
Anyway, should be there. Or around. Look, Christopher. See?
I just said, should we put more starch? Faster to beer?
It don't have to be that way. You can do it wrong. Yeah, that's fine. It's not like a grave couple.
Alright.
That's perfect. We just need to see the color change. You do not need to make a sausage, just a little one.
Iodine. Iodine should go with it. Where's the This was where the ethanol was?
Okay, so we got a Oh, so that's. Oh, let's start.
Yeah, that's more than enough. Yeah, we see the color change. I said you need to make a sausage. You need to make a hot dog.
I think both solid.
No closer.
You guys need. That's your
Oh, we need a different.
You can add water if you want.
Oh, where's the starch?
Add water.
We don't know.
Yeah, just add a little bit of water. Yes. Start right here. So just put this a little bit.
We need one.
Now, where's your solvent? Where's your solvent? Yeah, can I just put it in there?
Yeah, what's the smell like water in the bag?
This is supposed to get colored. Whatever is here.
I mean, you can, yeah, whatever, but you're gonna have, just put it up, what do you expect to see when you put it in there? What color change? Yeah, what color change? The solvent color is gonna change? No? The bag, yeah. So the bag is gonna change to what color?
For now, while that's
It's
happening,
gonna change to blue. Because iodine from outside went into the sugar. When iodine touches sugar, it becomes blue. The same way like the glycol turns amber brown when there is oxygen. So the same thing here. When it's starch, it turns blue. Perfect.
And we need another bag.
Do your job.
Okay, is everybody watching? Yeah.
How many jobs? I think it's inside the other end of that. No, we said it doesn't matter. We can look, but it doesn't matter.
They get supposed to, yeah. I need dip it.
So now work on the other two at the same time. Now we need to do the same thing but with different solvents. So get another beaker and use sodium hydroxide on the outside.
Do this, put it in the bag, and put the other side out.
Touch it.
So they don't cut the knife, you use the other bag.
Phenolphthalein, yeah.
Yeah, but why we ain't paying for it? I mean,
So ethanol, yes. Where is phenolphthalein?
My first name was meant to be
Josh was the wildest thing.
Okay, what are you doing?
Okay. Hold on, wait. Wait.
You're supposed to dissolve it in there. That's, it's not touching it, it's supposed to touch it. Oh my God. It's supposed to be, so how are you gonna get a reaction if they're not touching each other? Yes, and get it in there. Look. Now watch the reaction. You can type from the top too, yeah, you can.
But because there's that one, that's why.
Does anyone remember what kind of title we used for
Yeah, you can make your own bag.
Water and something else.
Wait, so we.
Yeah.
Just wait until you.
Oh wait, no, it didn't.
This is for water. You're not supposed to have a full type ethanol and phenolphthalein. Ethanol.
So what's in this one?
This
Yeah,
one,
what you guys put in this one?
there's supposed to be starch in here, starch and water, but it's only.
We got ethanol.
Wait, why do you keep getting?
Ethanol's right here.
Arrow needs ethanol.
Oh, that's ethanol right here.
Yeah, ethanol and iodine.
I thought that was iodine. Ethanol what? He said ethanol and wait, he just said ethanol and water?
Starch and water.
Professor?
Yeah.
Ethanol and water we're supposed to add.
There is ethanol and phenolphthalein, that's it.
Ethanol and no, I don't think so.
No, this is NaCl. Ask around, they have it somewhere.
Yes, we got it right here. You remember? I put this one, and then this is regular.
Did you guys add water? Add water here?
We're not gonna get to the
Make a new one. That's
So I put this in the same
So you just put NaOH here, and did you add water here?
Yeah. Wait, no, I put it, yeah.
Outside you need water and NaOH, that's it. Take a second bag, inside the bag you let it work a little more and, nope. Right there, phenolphthalein. We'll ask them what is the phenolphthalein.
So we're first years. Why would they give us names? Jonathan, Joshua, Chris.
With ethanol. Just add more phenolphthalein.
He's okay with that, okay? I'm tired of like
I want to find out what this is, bro.
Jenny from Blackpink. We're meeting up with Stephanie. He's getting wings off and telling you together. Yeah, I don't know nothing about Korean. I just know I love you. I know so much about that's why I think he knows the
Oh.
Guys, it turned pink.
Yeah.
With this yellow one. Yo,
Wow,
the yellow
like,
one. Did the yellow one change for you guys?
Here, are you sure you guys got iodine in this?
I think it's supposed to be in the rain.
Yeah, about that.
Yeah, you guys didn't put it in the.
In the meantime,
I'm about to.
My favorite shade of pink. Okay.
What?
what's happening?
I don't know. Oh, by the way,
What is creamy gun?
I went into a big, I just feel like it's
No, you gotta feel the glue.
How long do we have to wait?
here for like 5 minutes.
Maybe you guys added a little too much.
So should we start?
Let's try.
Oh wait, turn it on. Now we tied it the same way as we tied this.
Abigail, you want to get another number so you try doing it again? Another bigger?
Should we just restart?
Wait, everybody is.
The bottom is not the line.
But like, it's not worth it. Let's try to
Yeah, I was
We have water. Why don't you put it?
I need that sound too.
Yeah, but it's supposed to be
Yeah, no point in the
at least.
I swear to God, I just like this song. I think it has so
Wait.
You gotta make juice.
I feel sorry you're saying that. It's not like
Thank you to observe the music across the different.
Add
I'm really like shocked at this.
Now we tried to actually now we're starting the process.
Wait, so one of the two has water, and then we put like 4 drops of whatever, that was this one. And then this one would be 10 pages of starch. But then, no, but I think it was the problem this time, we did not drop any drops of NaOH, you know, in that bottle. We had that, we didn't do it. We didn't drop that in. It's the one with iodine and
Somebody made that.
drop that in here.
Oh, the hoodie? I mean, like,
And everything right. So do we drop it? I don't think we dropped it. I'm gonna observe others.
if you want to take the deep over the
Because I read the instructions and everything right. Can you hold it? And it's still like the same thing.
Yeah, we're trying it
So you get
again.
a proper
You did it different?
We're doing it now. I'm doing it again. Maybe we should add something else.
I said, like, you know that packet he goes to print out? It has the exact restrictions.
Maybe it's a different type of yeah.
Don't get me wrong, but I'm not like that. I'm a person that's
I know it's going away.
like I can't resist my emotions. Like I sit here, let me show you the Muslim prayer. What you wanna do?
It's not, it is. You see?
Where are these from? Utah. Actually, maybe more than.
You said you was 30. I said more than me. I'm like, bro.
Your last battle.
Oh, then your wife.
So they have added water outside.
I was thinking I should.
Yeah, like that.
Wait, how did you do that?
Do we have to add water from the bottom for the?
I think we already said.
Yeah, we added water.
You are. Yeah, we didn't add water.
We didn't add water to.
Wait, did you guys add water to starch?
So that's the problem.
Yeah.
How much you
Oh, it does.
Your last one was over. Mine gave me 210.
Yeah, I think they.
Hey.
This was 4 days before my birthday.
It turned blue. It turned blue.
Half the
I don't think we're supposed to replace
And what I wrote the thing is, when you think about water and storage, I was like, it's the when I opened it. Yeah, that's what I'm saying. Like, this, yeah. And it's dirty. It looks like a dirty thing. It is cool.
They mentioned that before.
Yo, read this line. Bro, read this line.
Bro, I don't know.
Could it be that water is
Don't do you know sometimes you gotta search.
We didn't put water.
It's changing now?
Yeah, there you
Okay, guys, look. There turned blue. You see?
Where do you
So blue.
Okay, so give you your stocks. Maybe you guys added too much starch.
What do you
Okay, How about this? Open up your bag, get out, push out, throw out half of it and add the rest water. Add more water. Add more water. Add more water. That's now you learn. When you add a little bit of water, you're gonna go
You're not.
throw half of it out and the rest of the water.
Don't talk. I gotta make sure I know what I'm doing.
If you turn your dialysis bag into blue, you're gonna get extra credit like them. You have 5 minutes.
But it's not gonna turn blue if I
Abigail.
Are we supposed to add something in this kind of and then what are we supposed to and then
Yo!
have a good question.
Extra
credit!
Yo, turn blue.
It did not.
Yeah, it did.
It did. Good. Okay. 4 more minutes. 4 more minutes. If you add too much, water is very important for mediating the process of the movement of the iodine.
You got an extra point.
We didn't add water, but iodine
You added more water to the starch, right? So why did it turn blue? By itself. 3 minutes! 3 more minutes!
Oh, never mind.
Right, we added more water to it? We added more water, right?
Chanel! Work faster!
I'm sure.
And it probably could be.
She said you
right
were.
amount. You probably did the right amount.
For the first experiment, it didn't work.
It didn't work because you had too much starch.
Exactly. You added the right amount.
You gotta find that out. That's your job.
Just add more, like less glucose and less water. Yes, I
Okay. Okay. 3 groups so far. The rest. Where are you guys? So where's your bag?
My bag. Wait, we have
Where's your bag?
Oh, I left it in the mixture.
What
I did not do that bad. Yo, someone ready to steal our extra credit.
Did you steal their bag? Oh my
No.
Where's your bag? If I don't see your bag, you're getting a 0. Don't worry about vouching. Where's your bag? I don't need vouchers.
Where's our mixture? Where's our
This one.
No, it's different. I was dark.
So where is it?
Dude, did someone drop? Did someone like touch your ether? Dude, I left the beaker right here. Someone took it.
Where is the one that was in the garbage? There was one like that was in the garbage. Where was it?
The garbage?
No, not in the sink.
In the sink, but that's.
Yeah. Okay.
What the fuck? Some y'all are grimy in here. Where's the beaker?
We lost the whole beaker. It's not
But
like
we still
lost-
have this one.
It's not like we lost the
but we
concoction. We
really
lost
don't
that.
have one.
Our whole beaker's gone.
Okay. Make another blue. Make another blue one. Everybody's blue. Cancel. Make another one quick so you can get credit. Quick.
What? Sir, that's not fair. You saw our.
Just make a new one. Don't complain. Don't. Yeah, make two. Just make a new one. Stop complaining. Just make another one. Make another one. It's not hard. Okay, try. Experimenting.
Is there more string?
You don't need a string. It's okay. Listen. All right. Okay. Enough, everybody. Now we have to clean up. We are so late. But I'll give everybody credit. I'll give everybody credit. Listen. If it did not turn blue for you, you have to speculate on why did that happen. Okay? Yeah. Okay. All right. Okay, guys. All right, clean up.
Our beaker is gone.
Clean it up. Stop working. Please put all the pipetters. Put all the use pipetters. Put them on the bottom. Use pipetters. Put it on the bottom. Use pipetters. Put it on the bottom. Here. Use pipetters. Everybody, use pipetters. Put it down here. Use pipetters on the bottom. Clean up your beakers. Please close all the solution. Put it back into the cart.
Wait, use my pen. Go on the bottom level?
Yeah, on the bottom, yeah. Okay, guys, can you please take those back to the card table?
Oh, yeah.
And that pipette too, if it's used, put it in the bottom. Rinse all of your beakers
Right here.
and drink all the stuff back.
celebrating it
Those
then.
guys, please, that needs the beakers and all everything back.
Oh,
Nico, you know what this reminds me of?
What?
What's the author's name? Stephen King.
Stephen King.
No,
Sorry.
I think he or she.
Yeah.
I don't know.
Make sure you go do your
Makes
quiz
like
too.
these mystery genres.
This is one of them. Because that was crazy.
Yeah, like how's that possible?
Can you extend it a little bit?
Yeah, you can do it now. It's so quick. You can do it now.
It's
Just do your quiz. Clean up and do your quiz. And go home.
Alright.
Did you do your quiz?
I'm gonna do it in the way to my house. Let's do it fine.
I think I need to do it now.
I'm just gonna do it.
Okay, Godspeed.
When is it shutting off?
Yes.
The one from yesterday, I tried to do it and.
Just email me. Email me.
You didn't.
Patting everybody
They took the
down.
whole beaker,
I'm
bro.
saying.
Someone's the whole beaker.
That's really jealous.
If they took the,
Okay.
if they took the, if they took